Shall I start? Okay. Oh, am I audible? Okay. Is my screen is visible? Okay. So coming to liquid system, unless it is hematology, this tubing diagram is very easy. Okay, this tubing diagram is comparatively hematology. This is very simple and easy to understand. Okay, so we are using 4 pumps here. In this analyzer, we are using 4 pumps P01, 02, 03, 04. Okay, and 7 valves. Entire instrument is having only 7 valves. So 01, SV1, SV02, 03, 04, SV 5, 6, 5, 6, 7. Okay, I just sorry. 4 pumps P01, 02, 03, 04. Okay, and valves, 7 valves. SV01, SV02 solenoid valves, 03, SV04, and 5, 6, and 7. And entire instrument is having only 3 syringes: syringe 1, syringe 2, syringe 3, and one wash preheater assembly. This is the wash preheater to maintain 37 degrees. Okay, 2 filters, which is instrument outside. There will be one filter which is connecting between the DA water tank to the instrument. There is a filter 01, and this is for filter 1 for water and filter 02 for detergent. And 4 tanks: tank number 1, tank number 2, tank number 3, tank number 4. 2 wash wells. As you all know, some mixer is having 1 wash well, and sample and reagent probe is having 1 well, and 1 sample or reagent probe. This is the probe, and 1 auto wash station. So auto wash station is having 4 probes, as you have seen in the first slide. So this is having 4 probes. So 1 auto wash station. Okay, coming to sequence. See, this instrument, as we discussed, this is a wet chemistry. Okay, in this wet chemistry we have what we are using is a semi disposable cuvettes. Means we have a limited specific period of time. As per the manufacturer, we are going to replace all the cuvette segments once in 3 months. Okay, so in this model we have a permanent cuvette system also, not in BS-240. If you go to the higher end models, you have a individual cuvettes. There also you have 2 types of cuvettes. One is a plastic cuvette, one is a quartz glass cuvettes. If you use quartz glass cuvettes, it's a permanent cuvettes, so you can the life of the cuvette will be more than 5 years. But here we are using a plastic cuvettes. In this cuvettes we are having limited lifetime, so with every 3 months you need to replace, and the same cuvette is using for continuously for different parameters, different analytes. So for that we need to wash the cuvette and reuse it. So that is the reason we are using instrument is consuming the water more. Okay, so the instrument is having in the first slide we saw the instrument behind we have connections, right? So 2 are the input lines, 2 are output lines. Like one tank number 1 is a deionized water. Tank number 2 is a detergent. We have we have to prepare manually 1:10 dilution of CD80. So 1 liter of CD80 diluted with the 10 parts of the water, and we have to connect here. Okay. So how instrument works, we'll explain. See, when you this is the syringe 01. Okay, when turn SV01 will turn on, this syringe will pull the liquid from the tank. Okay, this syringe filled with the water. When you do the first time priming, it will remove all the bubbles. After that, instrument is always having water inside the syringe 01. So we can this syringe 01 is connected to the preheater assembly, from preheater to the wash station dispensing lines, and simultaneously which is responsible for external wash of the sample probe, sample and reagent probe, and mixer washing purpose. So syringe 01 is responsible for cuvette dispensing washing as well as external wash of sample probe and mixer unit. Okay, so this SV01 when is on, this water is filled with the syringe, and it will turn on, and the syringe will push the liquid through the heater assembly to valve number 0507, and it will dispense the water into the wash station cuvettes. So if you see closely, cuvette wash station is having 4 probes, right? So, but in that 4 probes, only 3 probes are the dispensing probes, and one is a probe wiping. So it is to aspirate the water from the cuvette. So to effectively clean the cuvette, we are doing 2 times washing. For each cycle, we are washing the cuvette 2 times. That means probes will go down and dispense the water or detergent and aspirates. Again it will go down and dispenses and aspirates. Okay, so each cuvette it will wash 2 times. So that's why we uh, so it's a 6-step washing like, and the 7th step it will dry. So first step it will dispense water and aspirates. Again it will go down and dispense and aspirates. That means 2 steps over. Again disc will rotate clockwise, and cuvette will go forward. Okay, then there again 2 times it will dispense and aspirates. Again it will dispense and aspirates, means 4 cycles completed. Then again cuvette will rotate, and cuvette will forward to another probe, probe number 1. Okay, so here again it will dispense and aspirate. Sorry, I just wrongly direction. So first it dispense the detergent. Hello. uh, First it will once reaction before sample dispensing, it will wash the cuvettes, right? So first step it will this blue line is a detergent line. Okay, syringe 2 will aspirate the syringe, detergent from the external tank through the preheater assembly, and it will dispense the detergent to the cuvette number 1. Then this probe will aspirate the detergent from the cuvette number 1 to a concentrated waste tank. And again uh, every cycle will happen 2 times, no? So again this probe will go down and dispense the detergent. Again this probe will aspirate the detergent. So 2 cycles completed for one cuvette. Then cuvette disc will rotate, and this cuvette will move here. Okay, here it will dispense the water, aspirate, again water, aspirates. So this is a diluted waste. This purple line indicates diluted waste, low concentrated waste. Red line indicates high concentrated waste. and the blue line indicates it's a detergent, and the black line is a water dispensing line. Okay, so then it will clean the cuvette. Second probe will clean the cuvette two times. Then again disc will rotate, and the same cuvette will forward to the third probe. Here also again it will wash two times, and the second time it will dispense the water. After that water dispensed, it will go for the measurement. That is called cuvette blank. We have seen in the optical module there is a error called cuvette blank, right? Cuvette blank out of range. There we are mentioned after dispensing the third cycle, there is a wash water. It will go for the reading, and if the reading is within the limits, within the intensity limits, it will be okay. If it is below the limit, it will trigger the alarm, right? So after the third cycle dispensing the water, it will go for again, it will drain, then it will go for the drain probe. This probe will aspirate and clean the cuvette. It will remove the water from the cuvette. It is having a wiper. This probe is having a wiper. So it will go down two times and aspirate whatever residue in the cuvette. So it is directly connected to the P02 pump. So high power is applied from the vacuum applied to the pump, and it will aspirate and discard to the high concentration waste. Is it okay or shall I explain again? Okay. Uh, so just to understand, black lines are water. This pink line is a diluted waste, means low concentrated waste, and a blue line is a detergent line, and red one is a high concentration waste. Okay, so this is how washing will takes place. Each probe will wash the same cuvette for two times. So probe number one dispense and aspirates, again dispense and aspirates. So it washes the cuvette with the detergent two times. Then it will the same cuvette will forward to the probe number two, and here two times it will wash again. Simultaneously it takes place. Once the after three cycles completed, means six times washing will completed. In the sixth phase, it will dispense the water, and the cuvette will go for the validation to the. It will take the blank absorbance from the photometer. So once water is dispensed, this cuvette will go to a photometer. There it will measure the blank reading. It will compare with the previous reading. Okay, and simultaneously light intensity of the previous reading. If the difference is more lesser, means that there is a cuvette overflow. Okay, if cuvette is having any overflow, there will be a difference in the light intensity, then it will trigger this alarm. Okay, once that cuvette is got validated, the probe cuvette will come back to the fourth probe. Here this wiper will empty the cuvette. Here there is no dispensing. If you remember wash station, maybe I'll show you in further slides. Okay. So syringe 02 is only for dispensing the detergent. If cuvette washing is not happening properly, means you have to check this syringe 2 and syringe 1. So this syringe will dispense the water through the preheater assembly. Here two valves, each valve for each probe. Probe number 2 is connected to valve number 5. Probe number 3 is connected to the valve number 7. Okay. So if you have to verify whether this dispense water is adequate or not. Sometimes water dispensing may not be proper, because of that also cuvette wash will not happen properly. So you need to check these lines and valves. Okay. SV05 and 07 is responsible for dispensing water, and syringe 01 also. And the same syringe is responsible for washing the sample probe externally. So there is a valve number 3 which is in this line. Whenever you are facing issue, when there is a wash station jet is not sufficient, pressure is not adequate and all, you have to check this line. Water is coming from the side, not from the bottom, right? So it is coming from the side and it will fall into the probe. If that line pressure is not sufficient, you have to clean this line and this valve. Okay. And simultaneously this same line is for mixing cleaning also. Valve number 4, this line there is a restrictor to why we are using restrictor here, to increase the force. So speed flow, to increase the flow we are using some restrictors here, T2 221, T211. These two are the restrictors. Okay, increasing the flow. And uh, here water will come with a little force and wash the mixer and probe externally. Sorry, it is not a restrictor. There will be a restrictor. Okay, this is a connectors only, not a restrictors. But it will. You have to check whether the force is clear. Force water is coming with the force or not. You need to verify it. Okay. So if water is not touching the probe, also it will give the liquid alarm, liquid level sense alarm. Sometimes you are facing whenever it starts from the standby to measuring mode, it will verify whether water is touching the liquid or not in the wash station. If that condition pass only, then it will go for the aspiration, sample aspiration purpose. Okay, so if water is not touching the external water is not touching the probe, it will trigger the alarm. Okay, so and here P01. Coming to P01, see this 703 is used for sample aspiration, sample and reagent aspiration. Okay, once sample and reagent got aspirated and dispensed, we need to wash the probe internally. So for internal washing, this force is not sufficient. This syringe force, you saw that syringe is a small in size, maximum 250 microliters is the capacity. Reagent same syringe, no? So to increase to clean the inner line of the sample probe with effective clean, we are using P01. This will pull the water from the tank, and valve number through 02, it will push the water with the force. So to clean the effective wash, it will happen. Okay. So for cleaning inner line with effective wash, we need to use P01. This one also you have to verify whenever you are seeing this during the priming. You can able to see inner wash probe, inner wash washing, whether it is coming with force or not. Okay. And other than this, these are the lines for low concentrated waste. Whatever water comes into the wash well, it will go to the external tank, waste tank, with the gravity. There is no additional pumps used here. So whenever you are installing a new instrument, be careful. There won't be any bend or any it should be like a slant. You have to put the pipe along with the instrument. Pipe size will come, very big pipe will come, but you have to cut the pipe and make sure to connect. This water has to go smoothly to the tank. If it is not properly routed, the wash water will come back to the reagent carousel. Here reagent carousel, this wash water will come in and fill in the reagent compartment. So here we have a line, because this line is for condensation water. Since we are maintaining 2 to 12 degrees in the instrument reagent compartment, that there will be a condensation water. That condensation water will go through the waste line, and simultaneously from reaction carousel, if any cuvette overflow happens, that water also exit through the this line. Okay, this is a waste diluted waste tank. And coming to aspiration part, here I explained you about dispensing. Here is the aspiration part. So in P4, P3, we are using two pumps for aspirating the water from the probe number 1, 2, 3. Okay. So, and we are using dedicatedly P02, only one pump for the probe number 4. Why? Means we are going to clean this cuvette, right? There won't be any water bubble or molecule should be here. So to effectively clean that, we are using one wiper, a Teflon wiper, and we are applying the high vacuum from the pump 02, so that it will wash the cuvette effectively. So whenever that is the one reason why there won't be much liquid in this line, and you are observing lot of some deposit dust like this in this tubing, red color tubing here. Okay, red line, waste line. I hope you have understood. Okay, any doubts in this? Please ask me now. Okay, so as I mentioned, instrument is having two filters. Filter 1 is connected to the uh, deionized water input line, and filter 2 is connected to the detergent line. Okay, these two are consumables. You need to replace it on yearly. It is a part of PM kit. You can order through the PM kit. And since this is the main syringe for sample and reagent, so whenever you are replacing the syringe, you need to be take care of this. This area should be 7.5 exactly. Whenever you are fixing this area should be 7.5 bar on the scale. Okay, so this is a 500 microliter syringe, and coming to this syringe, we discussed syringe 01. This is going to dispense the water through the wash station and wash wells, sample and mixer wash wells. So this is a 10 ml syringe, and sample probe external wash purpose, and mixer external wash, and dispensing of wash station second and third needles. Okay, and it is driven by motor. And another syringe is a 2.5 ml syringe, and which is dispensing the detergent in the dispensing probe 1 wash station first needle. Okay, as we discussed in the fluidic diagram, we have 4 pumps. P01 will give high pressure water to clean the sample probe inner line, and P02 and 3 P02 is drains the concentration waste from the first phase of wash station. I'll show you here. So P02, this is going to aspirate concentrated waste from here to waste, high waste. Okay, then this cuvette will move here, and P03 will aspirate the water from the other two probes, second and third phase of wash station. So these two lines are connected with Y joint to the P03. So this is a concentrated waste and this is a wash water. Okay, diluted low waste. Okay, this is aspirating through the P03, and P04 drains the low concentration waste from the fourth phase of wash station. So coming to wash preheater assembly, we have two it is an entirely single module. One line is for the wash water and the other line is for the detergent. So for this wash preheater assembly maintains the 45 degrees temperature. As we see in the diagram, this is the preheater assembly. One line is a wash water line, another line is a detergent line. And we have 7 valves. As I explained earlier, valve number 1 is for with the syringe 1. Uh, Simple. Valve number 2 is probe interior washing. 3 is for the probe exterior washing, and 4 is for mixer washing, and 5 is a second phase water dispensing, and 6 is for first phase detergent dispensing, 7 is for third phase water dispensing. So here you can able to see clearly this wash station. Here you have 3 dispensing lines but 4 aspirating lines. Okay, so one is first aspiration line, second aspiration, third aspiration, fourth aspiration. Here the cuvette, and this is the wiper which we discussed, Teflon wiper, which is going to drain the cuvette and make sure there won't be any water bubbles in the cuvette. And as I discussed, 2 times of washing for same cuvette in one cycle. So this is called cycle. I'll explain you about a cycle. What is one cycle means? 18. One cycle of the means 18 seconds. Okay. This cycle, in each cycle, we are measuring, taking the reading also. So every 18 seconds, instrument will take the reading of the cuvette absorbance, and simultaneously same 18 seconds cuvette wash will happen. In the same 18 seconds time, a reagent will dispense and sample will dispense, and then the same within the 18 seconds time, mixer will mix. So simultaneously all the modules will work on the within 18 seconds of time. So as I explained, first needle for dispensing the detergent, second and third needle for dispensing water, fifth, sixth, seventh, eighth needle aspiration. Okay. So here you have a label 1, 2, 3, 4 inside and 5, 6, 7, 8. So here there is a sensor, wash station collision sensor. Most of them you will face this issue. This suddenly instrument will give a alarm wash station collision error. Sometimes there won't be any vertical obstruction, but it will trigger the alarm. So you need to check this sensor. There is a verification procedure. So there is you need to verify red and black. Between that, you have to you are able to see 1.2 volts. In the receiver side, green and blue. When there is no block, it should be 0. When there is a block, it should be 5. So sometimes this cable got up going up whenever wash station going up and down, this cable got bend and release. So because of that, sometimes over the period, this cable may have loose contact and wrongly sends the alarm. And sometimes you have to observe whether it is touching any cuvette or not. Wash station alignment you need to perform. So this is the procedure. Whenever you are facing and a wash station collision error intermittently, you need to verify the cable and sensor. This sensor comes along with the cable. There is no separate cable and sensor available. It's a small PCB and easy to replace. Okay, any questions? If no questions, we can go for the next topic. So coming to hardware system. So except for LLD board, okay, and pre-amplifier board, AD board, and RRB, BS-240 has one main board. This is the main board, one drive board, and one power board. So if you open the instrument backside cover, you are able to see this drive board. This is a driver board which is responsible for all the motors, pumps, valves, syringes, everything. And this is the main board. And here is the you can see small board which is a ISC power board. Instruments comes along with the ISC module. You have this board. Whenever you are upgrading the existing instrument in the upgradation kit, you will get this PCB. Okay, and this is the main power box. How to disassemble power box? So simple. You have to remove 4 screws and pull out the top cover and pull it little 10 centimeters outside and remove the power connection 230 volts 220 volts cable and turn it 90 degrees clockwise and remove all other connections. The board will come out easily. You have to disconnect all these cables and board will come out. And coming to power board, here you have a LED indications So a board is having five LEDs. So L12 is for 12 volts for lamp, which is controlled by software. Whenever you turn on the instrument, lamp is not going to glow. Lamp only glow. Lamp turn on only with the software. After turn on the software only, lamp will turn on. So it is controlled by software. And 5 volts is for analyzer switch, and B12 volts for reagent refrigeration. Whenever when you turn on the main switch, automatic 12 volts will apply to the supply to the reagent RRB PCB. And this 5 volt logic voltage, this is for the main board, and 12 volts P12 volts output for the analyzer switch, and 24 volts output analyzers. Whenever you turn on this analyzer switch only, this voltage will supply to the respective modules. Okay. And the heaters, as we discussed in a reaction compartment, you have a two heaters which is driving by 220 volts or 110 volts, which is directly controlled by the software and temperature sensor. Based on the feedback signal, it will control the power. So functions of drive PCB. This is the drive PCB, and here you are able to see this this white line. This is the part number of the drive PCB. Okay. So here the main functions are receive command signal from the main board. So here is the main board cable. There is a cable connected coming from the main board connected here. It will get the command from the main board, and it will control and drive stepping motors, GC motors, valves, pumps. So as we explained earlier, so these are the different pumps and valves connected here. Here will be the motors. So it will control the pumps, valves, and syringes, stepper motors, and provide 24 volts for reagent preheater. In the reagent probe on the top of adjacent to LLD PCB, there is a preheater. This board will give the supply to the preheater assembly. So this is the main PCB. All the parameters are stored on the main board. Parameter means alignments. All the alignment file, everything will be stored in the main board. So control software should be programmed for new applied main board. Whenever you are replacing this main board, you need to take the backup of parameters always. Store the parameters, and after replacing the board, there is a procedure. You have to restore the parameters. So functions of main board. This board is communicating with the PC. Communicate with the slave machine means it is communicating with the drive PCB, and receive AD signal and control adjust gain. So the photometer preamplify PCB, AD PCB is there. So from the AD PCB there is a signal line coming directly to the main board. So which will maintain the adjusting the gain, auto correction the gain. Receive signal of position sensors. So all the position sensors like vertical collision sensor, LLD signal sensor. So this will get the signal directly from the sensors. Do you need break, or shall I continue? Any questions? So I'll complete this module and we'll end today's session. So coming to software. So this is the software one package with operation including alignment menus. See, in a previous version you have a operation software separate and control software is separate. So if you want to do some alignment, you have to exit from the software and you have to open the another alignment software separately. Here, which is one package, it is included along with the alignment. Okay, so whenever you installing new instrument, here software version will give the idea whether instrument is open model or closed model. As you all knows, open means you can configure any kind of reagents. Closed means Mindray dedicated reagents. Here is the software package version. So whenever you find instrument is having older version, try to upgrade it. Okay. Sample positions can be defined with the adapter. As I explained in the reagent compartment, so in that on outer ring you have 40 positions, right? That 40 positions you have to use only for the samples. If suppose customer is having more samples, so he is not using all the parameters. Some of the reagent positions are empty. You can make those area also use it as a samples. Then you have to configure how many positions are the sample positions. You can make it 50, 60, up to 80 you can make it. Means outer ring and middle ring you can use it for samples completely. And whenever you are installing along with the optional modules, that means ISE you have to enable here, and sample carousel barcode and reagent barcode. So you have to enable based on the instrument configuration. If you don't have ISE, no need to enable this. And here is the maintenance menu. So you have to go to utility. From here maintenance, in the maintenance you have three options: maintenance, alignment and parameters. So in the maintenance you have a scheduled daily maintenance, weekly, 2 week, monthly, and 3 months, 6 months and others. So you have to guide technician properly to follow all the maintenance procedure as prescribed. Hello. 2 menus for resetting count to 0. Suppose whenever you are replacing any pumps or syringes, you have to make it reset. Okay. We have two menus. If you want to make it, suppose you change the syringe, so already it will show some cycles it is completed. Whenever you are replacing, you can reset the syringe to 0. Okay, so you have option in the maintenance engineer. Here you can make it clear. Okay, you can select that particular one and select all and okay, then it will get 0. And the simultaneously in another option, alignment screen, empty fluidic tubes, 5 pump maintenance option. Here also you can make it 0. Means whenever you are changing the pump, we are using 4 pumps, no? So we have some limited life wear and tear parts. So like example, if you see exterior and cuvette wash syringe, 6,000 times it is completed. Whenever you are replacing, you just select this okay, then it will start from the 0 and it will give us idea after replacing how many cycles it is completed. Whenever you are going for the PM, start observing these things to prevent future breakdowns. Okay, so you need to observe these things and make customer inform customer there will be a chance of failure. You can keep it in the stock or replace it in the coming PM. Okay. Upgrade entry for control software upgrading. So whenever you are upgrading existing software, make sure there is a upgrade tool, on D drive, Mindray. So there you can find this upgrade tool. Make sure this serial port you has to be selected, and modules, all the modules, all units, and the destination folder. You have to select this is the destination folder and start. Okay. So then main unit files and select start. This is a just you have to go through the procedure step by step. It is very clear in the manual and upgrading manual. Okay. So this is a step. First step you need to do all units, then you have to do main unit. After completion the upgradation, download, you will get a message like this, downloading finish. Then turn off the main switch and restart. Whenever you are formatting EEPROM, you need to make sure these are the parameters you should make a copy. Okay, so this sheet comes along with every instrument. Here it is indicating how many there is a parameters means whenever this sample probe example I am explaining about a sample probe. What is the main position of the probe? Center of the cuvette. That is the main position. So you don't have much adjustment play for cuvette, right? Cuvette width is 5 mm. So to center of the cuvette is the main reference point. You have to adjust cuvette area only, sample probe. All other positions you can adjust with the steps, motor steps. So that's why they have in the factory they will define all these parameters. These are the steps you need to verify at the time of installation or whenever you are replacing the main control PCB. Make sure this parameter file values should be entered. Okay. If you have backup, you can restore it. If you do not have a backup, you have to enter manually these values in the software. Understood? So always along with the instrument, this sheet will come. Keep it safe. Okay. It is useful while mainboard is defective or format EEPROM is executed. So here is the that you I told no this sheet values we are entering here in the parameter configuration. You have it module wise you can select. This is the sample and reagent unit, so you have to enter all these values if it is deviated from the sheet. At the time of installation you observe whether instrument is having the same value or not. If not, you need to adjust, change these values. And this is about wash unit. So is wash fluidic prime performed 1 times. This is the values for the reaction unit. So photoelectric gain. This is the values normally given by factory. You have to enter these values. And alignment photometric unit. See, whenever you are doing alignment of photometric unit, there is a option called signal collecting position. See, in the cuvette width is 5 mm, right? Where you want, what we are using is a spot photometry. Means cuvette will come in front of the lamp or photometry unit. Okay, it should be center of the cuvette. We need to take the measurement at the center of the cuvette, right? So it is not the left side or right side. We need to, so we are calling it as a signal collecting position. We can adjust based on that, adjust the sensor, so that we can take the right center of the position, we can collect the signal. So, and this is about sample and reagent carousel adjustment. You just click the tab and you can follow, as the guidance is very clear. You can follow step by step, and you should have a alignment tools. Whenever you are adjusting these alignments, make sure you have alignment toolkit. Go with the alignment tools, or else you can use, generally it is not recommended, but you can give the judgment by seeing. Okay, so this is about probe unit. So horizontal, uh, this sample and reagent probe for alignment, you have a different positions, right? Rotation and up and down. So you have to, if you want, if you feel the probe is not correctly aligned, you have to go through the procedure step by step. Each position, whether it is rotation, horizontal adjustment is required, or vertical adjustment is required. Based on that number of steps, you have to increase and decrease in the parameters. So different positions. Sample probe is having how many positions? The probe will go to a wash well position, right? Wash well, reagent sample position means outer position, outer disk. Okay, reagent disk outer position, that is a sample position. Inner ring and middle ring, four positions, and cuvette, right? This sample probe will go to all these places, so you have to verify alignment on in the all the places. Okay, and simultaneously vertical positions also, every position you have to make horizontally center, and vertically also you have to verify how much deep it is going, and you can adjust accordingly. So probe wash well vertical position, sample to reagent carousel outer ring, middle ring, inner ring, and probe vertical limit position reaction carousel. At the reaction carousel, your probe has to be certain height. You have to verify there is a tool. Probe vertical limit position on the reagent bottle. So suppose customer is saying a lot more volume of reagent left in the bottle, and he is not getting sufficient test. You need to verify this vertical limit position on the bottle. Okay, so probe to horizontal position to ISE. This is for ISE position, up and rotation, as well as vertical. And mixer, so mixer is having a horizontal position and wash station position, right? Cuvette position as well as wash position, and there is a vertical height up to it is not supposed to touch the bottom of the cuvette. So that is why it is important. Vertical mixing, vertical position adjustment also very much important. Whenever you are finding some noise from the cuvette wheel, you need to check whether mixer got bent, or it is hitting the sides of the cuvette, or it is touching the bottom. So normally sometimes during the installation, we are not fixing the mixer properly. It will touch the bottom of the cuvette, and it will create noise. So wash station alignment, you have a this wash station probes you have to verify, and it is to touch the bottom but not too much. Okay, just you have to verify that there will be a tool for wash station height adjustment. You have to follow it. Home position, height, and segment configuration. And a barcode unit, as you know, this barcode is used for a reagent scanning purpose, so you have to adjust accordingly. So this is a hydro unit. You have four options. You can verify the sensor status, and means individually all the valves you can verify, and floating sensors like DNS water tank is having a floater, detergent is having a floater, and waste also having a floater. So these float sensors are working correctly or not, you can verify. And the pump alignments, and you can verify the syringe check, whether syringe is having bubbles, it is uh, moving smoothly or not, and any jerks are coming, you can observe. Fluidic prime, the time of installation we used to do fluidic prime. Probe syringe return volume alignment. Probe syringe return volume. We need to adjust the whenever probe is syringe is dispensing the wash water. Again, it will pull back some water, not to completely, but it will pull back, not to have dripping on the wash station. So you can adjust. Means it will push. Suppose it pushes the water, and it will pull little bit backward to not to dripping on the cuvettes or any other place. That volume alignment also we can do. So here is the floater pump alignment. So these are the valves we discussed. Up to 7 valves we have. Individually you can verify the valves and wash solution sensors and pumps. Okay, these are the float sensor, tank, rear tank wash tank sensor, detergent tank sensor, high concentrated waste sensor. You can verify whether sensor is working or not, and here you can verify the pumps are working or not. Okay. And coming to pyrology, in the pyrology unit, you have two options: reaction corrosive temperature you can check, as well as reagent compartment temperature also you can verify. So here you can turn on the heaters, you can verify sensor feedback signal. By seeing this, you will come to know whether temperature is stable or not. So it will two sensors will give feedback signal to the board. So based on that, power is applied to the heaters. And this is for is water heater and wash water heater. So as we discussed, 45 degrees it's supposed to maintain. So we can able to see how these heaters are working. This is a pump maintenance. That's all. Okay. Any questions? Just hold on line. So any questions related to hardware or fluidic? Hello, am I audible? Okay. If no questions, we can complete close it for today. Thank you for joining. Thank you all. You have tomorrow's link, right? Separate link.